So we're going to do a second lesson on calculating volume. I just want to go through some more examples, make sure you understand what it is that you have to calculate and have a fairly solid understanding of calculating volume. There's nothing new in this lesson that wasn't in the last lesson, but there are a couple tip questions in here that you will see on SAM. And they are questions that were very similar to block release questions. So if you need a little motivation to actually go through the lesson, there's my carrot that I'm dangling in front of you is there's a couple questions in this lesson you could possibly see in the future as you work towards block exams. So, and I'm really not going to recap much from last lesson other than we'll have a couple of conversions that come in. We'll just kind of dive in. So we want to calculate the volume of this object in cubic inches, and I want you to round to the nearest cubic inch. So how do you go about calculating the volume of this? This is none of the formulas we dealt with last class. Well, it is, because volume is equal to area times, I was going to use T for thickness. Depending on the context of the question, we can use height, thickness, length. There's a number of different words. So it's kind of up to you to think about which word makes the most sense for the context. So here's our object. So the shape that's the same the whole way through is this large L shape. Now you can probably figure out why I'm giving you an L shape. Oftentimes in building, when we look at floor plans, we're going to deal with L shapes, and you'll see that coming up in the next couple lessons. So if we can figure out the area of the L, we know how high the L is, so we can calculate the volume. So the first thing we need to do is we need to know the area of the L. So how do we figure that out? Well, the first thing I'm going to do is I'm going to break this shape into two sections. You can break it a couple of different ways. The way I broke it apart was I just drew a line across there. I said, I've got one rectangle here. I'm going to let this rectangle be A1. Plus, I have a second rectangle, which is A2. If I add those two together, I get the area of a whole L. So what is the area of A1? Well, it's length times width. We have 15 inches by 14 inches. Plus, we need the area of 2. Well, it's 5 inches here, but what is the length this side of the rectangle? Well, we know it's 11 inches the whole side, so this side here must be 11 minus 4, which gives me 7 inches. So to find area 2, it's going to be 7 inches. I have 14 inches and I meant to write a 4. So I'm just going to erase that while I see it. Otherwise, sometimes I forget to go back. If you're wondering where the 14 came from, there is no 14. It should have been 4, typo. So area 1 was 15 inches by 4 inches. Area 2 is going to be 7 inches times 5 inches. Putting those together, if you put that into your calculator, you will get 95 inches squared. That's the area of the L. But how much volume does it have? Well, to find volume, we're going to take that area, 95 inches squared, and we're going to multiply it by, in this case, I would probably use the word thickness, just because of the way it's rotated. You could say the length of the object. You could say the height of it. You can use many different words to describe the same thing. Multiply by 2 inches gives us 190 cubic inches of material or volume. Okay, so pretty straightforward. Now, when you do a question like this, when we talk about concrete floors, you'll see the shape show up. And in that case, we're always going to say, instead of height, we'll use the word thickness, just because it makes sense for the context. Example 2, we want to calculate the volume of the object in cubic yards and round to 1 decimal place. The first thing I notice when I look at this one is I have feet all over the place and I want cubic yards. But when I look at this, I have to make a decision. Am I going to convert now, or am I going to use the skills learned from last class to convert at the end? If I convert now, I need to convert 5 measurements. If I wait and convert at the end, I only have to change 1. Because it's not as easy as just moving a decimal, this is a scenario where I would decide to convert at the very end. Underlining that what you need to have for your final units can be really good, because what it helps you do is sometimes go back and double check that you have those units. So we're going to do this question the same as the last one. We're going to figure out the area of the end. So I'm going to split this way. It doesn't matter really which direction you split it in. This one's actually going to make it a little easier for us. Why would we not use this area here for our area? Well, the reason being, if you're wondering, the reason is it's not the same the whole way through. It would be the same through just this section of the object, but then I'm going to have to change the area for this little L corner. It's going to have a different area and a different thickness. So I always say, pick the area that's the same the whole way through. And this L shape goes the whole length of the object, at least from what we can see. So to find the area, we're going to do the same thing as before. I'll call it area 1 and area 2. Area 1 is 2.1 feet. And if this height here is 4.5, then it's 4.5 there as well. So 2.1 times 4.5, and that's feet and feet. Plus, we need to add in the second area. It's a rectangle again, so we're just going to use our rectangle areas, 8.3 times 2.5. Right, and again, everything is in feet, so our area is going to be in square feet. We're keeping things in feet till the very, very end. If you put that into your calculator, you will get 9.45 feet squared plus 20.75 feet squared gives me a total area of 30.2 square feet. Now we need volume. Volume is area times, in this case, I think length would be the best word to use. Area times length, you can think of it as height. You just have to visualize it, rotate it. That's going to be equal to 30.2 times 7.6. 30.2 square feet times feet again is always going to give us our cubic feet. And that will leave us with 229.5 cubic feet, which is equal to, we got to switch to yards. Remember how to do that? 1 foot is 3 yards. Let me undo that. Remember I said I have those dyslexic moments? Mouth engaged before brain engaged. 3 feet. 1 yard is 3 feet. That's the direction I meant to be writing it. Which means 1 cubic yard is equal to 3 cubed. 3 times 3 times 3 is 27. So we need to take this measurement, we're going to divide it by 27, and that gives us 8.5 cubic yards. Why would we want yards instead of feet? Again, it's just a common unit that's used, especially if you're doing any kind of excavating. Oftentimes we use cubic feet or cubic yards in order to describe how much material is being used when you're working with soil. All right, example 3. So I didn't turn my page there, I might want my notes. So in this question is the type of shape that is common to get on the block exam. Just a heads up. So if you're looking for one of those questions that you may see, this is a question that is the same shape, but just different measurements. They often will talk about a concrete barrier. If you want to visualize those concrete barriers, is sometimes used to block off parking lots, and that trapezoid shape on the end, it's what the questions often refer to. will make sure the second SAM quiz has one of those for you just for the sake of practice. So you want to calculate the object in cubic feet and round to 1 decimal place. Now, if you look at this, everything here is already in feet. We know we don't have to convert. We just have to think about what's our formula for area, and then how thick is the object, or how long is the object, how high is the object, whichever word you choose to use. So the trapezoid shape is the shape that's the same the whole way through. So we need to find the area of this, and then our height is going to be this 2 feet, or you could think of it, maybe we'll think of it as the length of the object. So first of all, what is the area? Area of a trapezoid, big B plus little b divided by 2 times the height of the trapezoid. So 20 plus 14 divided by 2 times 19 gives us 323 square feet. If we want to know the volume, 323 square feet. Whoops, it's a squared, not a cubed. It's way too complicated to erase on this. It needs to be an easy way to have an eraser on the pen. Like you should be able to flip it around and it would automatically engage the eraser. One of you guys wants to inspire some creator to come up with a new product. I'm sure, given the results of the pandemic and how we've switched to so much online learning, and it's probably here to stay in some regard. I tell you, I'd pay good money for one that would work the way I wanted it to. So multiplying these two together, the area times the thickness or the length of the object, we get 646 cubic feet. Pretty simple. And you didn't have to round to 1 decimal place. It wasn't necessary. I just threw that in there just in case. Now this question is the next question. We want to know what's the volume of the object in cubic meters. Now this is a question that's taken exactly from SAM, and because of that, I want you to pay close attention how we solve it. If the triangular end is equilateral, that means all the sides are the same, measuring 1,200 millimeters, and the length is 3.4 millimeters. So we're looking for the volume in cubic meters if it's equilateral, the sides are 1,200 millimeters, and the length is 3,400. So Sam will give you a diagram like this. And what I would recommend doing is writing out the lengths. Now, we want cubic meters. This is a scenario where even though I've got multiple numbers, I would convert first because it's just a matter of moving the decimal. So from millimeters to meters, we're going to change our decimal 1 place. So the length, instead of being 3,400, is going to be 3.4 meters. The side is going to be 1.2 meters. It's going to be 1.2 meters here. And on the other side, 1.2 meters. Now, if you recall, the formula for the area of a triangle is 1/2 base times height. If you look at this particular triangle, you do not know the height. That's still a question mark. But you know the process to get it. It's one of the reasons why we went through Pythagorean theorem. So how do we get it? Let's draw the right triangle. So we're just going to draw half the triangle, and we'll use that to do our calculations. So we want to know what's the height. We know one side of it is 1.2 meters. And if we only have half of the bottom, we're going to have 0.6 meters. So we can plug those in. This is our hypotenuse. So 1.2 squared is equal to h squared plus 0.6 squared, which will leave us with 1.44 equals h squared plus 0.36. Rearranging, we get 1.08 equals h squared, and then you take your square root. H is equal to 1.04 meters. The reason it's in meters is we switched all of our measurements to meters. Now we can go back and we can calculate our area. Now when I calculate the area of the triangle, I know that this height, that's the whole height, is 1.04 meters. I do not need to calculate just the little side of the triangle. If I use the whole base times this height, that will do the triangle for us. You could think of it as two triangles like this, but it's actually a little easier the other way. So this is equal to half of 1.2 as our base times a height of 1.04 leaves us with an area of 0.624 meters. Now, if I want to know the volume, I'm going to take my area, so 0.624 meters, should be a squared, times the length of 3.4 meters. So meters squared times meters will give me meters cubed, and you will get 2.12 meters cubed. Okay, and Sam will tell you where to round exactly to. Keep some extra decimals if you're uncertain. It's one of the tricky things about area questions is with area questions, there's a lot more steps in them, so you have to be a little extra careful with them. I won't give you as many practice sheets just because I'd really like you to do the practice in SAM. Just because if I give you practice sheets, oftentimes people skip doing them. But if I give it to you in the form of a SAM quiz, they actually do get done, and it ensures you get the practice and you get to check your answers. Every once in a while there's a glitch, but we'll try to fix those as soon as I notice them. Question 5 is another question that's a common style question in a block exam. This question, I've had students before and they've taken the course after attempting a block exam the first time. And I know when they see this question, they always say, oh, that's so close to that question. I think that's a circular driveway is what's often used, like a semicircular driveway. Sam has a question with a quarter circle driveway. In this case, we're putting a sidewalk around a flower bed. The sidewalk is 100 millimeters thick. And I want to know what's the volume of concrete if the outside diameter is 10,900 millimeters and the inside radius is 3,950 millimeters. The first thing I would do in a question like this is I'd kind of make a picture. So we have our flower bed. There's the outside and the inside. So here's my flowers. Okay. I want to know what's the area of the ring. Okay. Now it just looks like a donut. Sorry. I've been recording too many lessons today. So if I say silly things, go a little rogue on you, my apologies. All right, so we need to figure out what's the area of the shaded donut. Okay. So in order to figure out this area, I need to know the area of the big circle minus the area of the little circle. So I'm going to say I need to know the area inside. Oops, not inside first. I want the bigger one first. Area outside minus area inside. Now this question, I missed leaving in a couple words. Calculate the volume of concrete and required, and we're going to go in cubic meters. I know it doesn't say that I'll adjust it before I post the sheet. We want it in cubic meters because if we do this in millimeters, we're going to get massive numbers that are just a nuisance to work with. So we're going to switch everything into meters. So we have 10,900 millimeters is going to give me 10.9 meters. 3,950 is going to be equal to 3.95 meters. And 100 millimeters is 0.1 meters. So just kind of doing all of our conversions. So how do I figure out the area of the outside? Well, it's going to be pi r squared. What is the radius of the outside? Well, we have to divide this by 2. And the radius is going to be equal to 5.45 meters. Minus, we got to subtract the area of the inside. So again, it's pi r squared. This time we know the radius. It was given 3.95 meters squared. Putting that into your calculator, you should get an area that's equal to 44.3 meters squared. To find the volume, 44.3, so the area, times how thick the object was, which is 0.1 meters. So area times thickness. That is going to leave us with 4.4 meters cubed. 4.4 meters cubed is the amount of concrete that would be needed. Now that you know that, you could actually figure out how many bags of concrete you would need. Now, a practical application of this, it was 2 or 3 years ago. I think it was 2 years ago. We had to put a sump pump into our house, and we actually had to put a trench in and put some drainage pipe underneath of the floor to help drain water out where it was supposed to be draining. And it meant we had to cut a large hole in the concrete, a large trench in the concrete floor. And we were working at this exact section when that came up. And that was, pretty well 2 years ago, almost to the day. And one of the things that we had students calculate that day was using the same process as this. We figured out what was the area that we had cut out, how thick was our concrete floor, and then we figured out, well, how many bags, how much concrete do we need, and how many bags of concrete would I have to buy and mix. So there's some really good, you might say, well, I'm never going to do a sidewalk, but that's a really practical example. Another thing that we're looking at doing this summer is putting in a drain in our garage floor to help drain water off the cars. It's more for winter time that we want to do that. And one of the things that we'll have to do is cut a trench in the floor, but I know the drain that's going to go in, it isn't going to be exactly the size. And then some of the hole is going to have to get covered in. So you use the same process to figure out what's the area of the hole, how thick is the area that you need to fill, how much concrete, what's the thickness of concrete that you want, and then you're able to calculate the volume, figure out how many bags you need. It's really, really convenient math, and I'm not a carpenter, and I still use it rather than needing to call somebody sometimes. So it's really practical math. It's good to make sure you know how to do it. Last question for this lesson. Again, this is a question that is a common question that has shown up on the block exam. Not saying it will be this year, but this gives you a good sampling of 3 types of questions that are slightly complex questions. The trapezoid question is probably the easiest one, but people forget trapezoids. That's what makes it complicated. The circle around the garden, you have 2 areas to calculate. That's what makes it complicated. Yes, it's going to be a multiple choice question, but even with multiple choice question, they're going to give you the obvious wrong answer, like the wrong answer if somebody forgets to subtract the middle of the circle. This is another type of question, and it's just got 2 shapes in it. And they're looking to see, can you recognize the shapes? Can you calculate the area and figure out the volume? Okay, and I know I said multiple choice for your block exam, and it is, but a well-written multiple choice test is often more difficult than it is when it's just a calculation, partly because they give you all the common errors, and sometimes you only have to calculate and pick the answer rather than going the whole way through. So that's just a little tip for multiple choice tests. Make sure you complete them just like they're a test that doesn't have multiple choice. You do all your work out first. Safe guessing is a last resort. All right, so to do this question, we're looking for the cubic meter volume again of the object. I feel like I missed a question, but I don't think so. No, good. So what's the cubic meter volume of this object? If the radius is 900 millimeters, the height is 2,160 millimeters, the length is 3,350 millimeters, and the base is 750. Now, this is a question that comes from Sam, so I'm going to tell you right off the beginning, double check, do they want millimeters or meters? Usually, they'll give you measurements in millimeters and want meters, which is the case in this question. So we are looking for cubic meters. Because we're looking for cubic meters, let's convert right at the beginning, because it's just going to leave us with really big numbers if we leave it to the end. So whenever we're dealing with meters, we're smartest to convert first. If you're dealing with feet and inches, it's often just as easy to leave it till the end. So our radius is 0.9 meters. The height is 2.16 meters, 3.35 meters, and 0.75. Just as a tip, the numbers that people convert wrong tend to be the first and the last one, mostly because they'll put 0.9 instead of 0.09. So watch for that. Little thing to kind of keep an eye out for is making sure you move the decimal the right number of places. Now let's look at our diagram. What shapes do we have? Well, if we cut this across the middle, across the crosshair here, the bottom is a trapezoid, and then the top is a semicircle. Easy enough to calculate the area of. So for the semicircle, the area of the semicircle, because it's a semicircle the whole way through the top, it's trapezoid the whole way through the bottom. So what we'll figure out is the area of these two combined and multiply it by the length. The area of a semicircle is going to be half of the circle, so that's where the half comes from, times pi times the radius of 0.9 squared. Putting that into our calculator, you will get 1.27 meters squared. Plus, we need to add in area of the trapezoid. I always feel like I put an A where there should be an E. I'm known to do things like that. I used to spell my name Elizabeth instead of Elizabeth because I just would flip letters. You guys have been kind enough. If I have got it wrong a couple of times, you haven't told me. So the area of a trapezoid is our big base plus the little base divided by 2 times the height. Okay, so the big base is across here, which is all the way across the semicircle. This is the same as 2 radiuses or our diameter. So we're going to use 0.9 times 2. So our big base is 1.8. Okay, so this base, I'll call this big B, equals 0.9 times 2. Throw an arrow in there in case you're looking for it later. So 1.8 plus the little base is the bottom, 0.75 divided by 2 times a height of 2.16. And if you put that in your calculator, you will get 2.754. So the total area is going to be 1.27 plus 2.754 leaves us with 4.02 meters squared. Now we know to know the volume. 4.02 times 3.35 leaves us with 13.5 meters cubed. So fairly straightforward, nothing really too complicated. It's just thinking about breaking things down. Remember when that question that I asked about the root question where how would you take something complex and make it easier to calculate? Everybody told me you need to break it down simple. So I want you to do the same thing with each of these questions. Remember, break them down simple. The simpler you can keep them, my husband always says, keep it simple, stupid, whenever he gets in a mess. And it's a good principle. It is a good principle. Just when you get stuck on something, oftentimes we overcomplicate things. I can say that from personal experience. So break it down to the simplest possible. And then once you have your simple shapes that you know, see, can you combine them together? All right, so that finishes off this section of volume, and we'll be into concrete foundations and floors next class.